Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your module, that is Procedural Programming module, and I'm continuing with the chapter number 12, that is the file input and output. So let's discuss with what we have covered in the last class, then comes forward to the today's topic, that is continuation of the chapter number 12. In the last class we have studied about the text file and the binary files. That is, what is a text file and what is a binary file. So far we have discussed that what is a binary file, what is a text file. Now it is a time to discuss in detail what is a binary file in C language and what is a text file in C language. This is all the programs that we wrote in this chapter so far worked on text files. Some of them would not correctly work on binary files. A text file contain only textual information like alphabet, digits, special symbol. But the ASCII values are stored in the text characters. A good example of any C program, say pr1.c. This is the example. As against this, a binary file is merely a collection of bytes. So a text file means a collection of the codes, digits, everything. But a binary file is nothing but a collection of the bytes, collection of the bits that is available in any C language program, that is available for any marketing, for conversion, anything. So that is a binary file. So in simple terms, text file contains data about the fact, about the data, about the text, about the alphabets. But when we talk about the binary file, that contains only binary number that is in zeros and ones, right? Then we have discussed about how to copy the data and how to execute the binary file by using any example. This is the example that is used. This is the example that is searching for the file, uses the file, end of the file, and searching the new files. Then we have discussed about the text versus binary mode. Means what is the difference between the text file and what is the difference between the text in the binary mode. Means how to insert the new lines and how to insert the end of the file, and what is the difference between the inserting the new line in the text. Yeah, are you able to hear me right now? Hello, hello, hello. Yeah, Larry, are you able to hear me? Hello, 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 hello. All right. In this class, on the last class, we have discussed about the comparison between the text and the binary mode. Means what is the difference between the text file and the binary mode? The difference. I'm unmuted. Now you got my voice. Is that audible to you? Okay. We have discussed about the comparison between the text file and the binary file on the basis of the new line, on the basis of end of the file. And the third difference is on the basis of the storage of number. So there are three differences: on the basis of lines, that is number of lines; on the basis of end of the line; on the basis of storage of the numbers, means how much or how the data will be stored, that is the storage of numbers. The only function that is available for storing number in a disk is the fprintf function. So this is the fprintf function that is used to store the number, that is storage of numbers. It is important to understand how numerical data is stored on the disk by using the fprintf functions. Then we have discussed how numbers are stored as a string of characters. Therefore, 1, 2, 3, 4 even occupies 2 bytes in memory. Why? Because 1, 2, 3, 4 becomes the data, or becomes the character in this, or integer in this type. Then we have discussed about record, input, output revisited. That is how to take the input and how to give the output, that is revisited. The record, input, output that we have discussed had two disadvantages. What are the disadvantages? Means it takes, first of all, more bytes than the requirement. That is, it takes more bytes than we require. Then if we increase the structure, if we increase any element, then we have to modify each and every element of the structure. This is the program that we have discussed in last class. That is how we can use the file operations. What is the file pointer, what is the character, how much structure will be used. Then we sorry. Then we will discuss about detail, what is the argument, how we can use the argument, how we can record the data, or how we can read the records from the binary file and display on the video. Video means video display unit. Then we will discuss one example that if it is equal to null, simply printf cannot open the file exit, and then uses the fread function for reading the data. Then we will discuss what is the usage of fread, that causes the data read from the disk to the placed in the structure variable E1. Means it reads the data like a scanf and puts the variable in the memory under the variable, this is the example, under the variable E. This is the same as we done with the fwrite. Fread returns the number of records read. That is, this fread is used to get the data and store in the memory when it is required. It is similar to the scanf function. Then database management. We have discussed another topic, important topic, that is what is database management, how we can use the database management. So in any serious database management application, we will have to combine all that we have learned in proper manner to make sense. In this we have to make the database, how to add, how to modify, how to list, and how to delete the records. These are the various examples that we, or these are the various criteria that we discussed before getting into the program. This is the whole program that is discussed. This is the whole program, how we can store the data in the type of database in the file management system or the file input output, so that we can maintain the data. There are multiple listing like 1 2 3 4. Then we have declared one variable, structures, how to use the file pointers. So we started with the header file. Then there are two file pointers that is used, one is fp and one is ft, and there are two variables that is declared, one is another, one is choice, and this is the structure variable that is used. Then char 40 int age float bs, this is an structure variable that is used. Then uses the char emp name long int resize, so this is the example that is used. Then this is fp equals to fopen, that then we have used the fopen function to read the or open the files. Then check for the null. If it is equals to null, then open the file in the wb mode, and then again check for the null character. If it is null, then can simply puts and printf cannot open the file. Then uses the rect size, that is equals to the size of e, means we have used the, or we have taking the size of the structure, that is the e, and then our structure variable e, and this is stored in the rect size. Then uses the while one function. This is the we have discussed about the go to xy, means where it is stored, which is the column number, which is the row number. First one is the column number, so 30 is the column and 10th is the row. 30 is the column and 12th is the row. This is the xy, that is the column number followed by the row number. Then this is 30th column, 14th row, 30th column, 16th row, means these are displayed one after the another within the lines, that is within the rows. After one row, that is 10, 12, 14, 16, 18, 20. Then this is another loop that is used, that is a switch case is used. Then there is a case 1, case 2, case 3 we have discussed. This is rewind fp, then uses while loop. Then case 3, this is another case, again printf and the scanf functions are used. Then this is the case 4. What is the case 4? These are the various cases that is used. This is the case 4, that is to delete the records. Then this is the last record, this is the last data that we use. Then we have discussed what is the use of each and every function. Means what is the use of fopen function, what is the use of fread function, what is the use of fwrite function, and what is the use of rewind function that places the pointer to the beginning of the document, beginning of the file. In the same way we discuss about the fseek function, means what is the use of the fseek function and how we can move the pointer from one record to the another record. Yeah, Larry, are you able to hear me? Larry, are you able to hear me or no? Okay. Because you are showing offline, that's why I'm asking. Okay, okay. Because you are showing offline, that's why I'm asking. Okay, okay, okay. Thanks. Then we will discuss about how to use the rect size and what is the use of rect size that moves the pointer back by the rect size bytes. How we can use the seeker, that is the macro that is defined in stdi.h. In the same way, we use the fseek function that would place the pointer beyond the last record in the file. This is the fseek function that is used. There is the fp, that is the file pointer, 0, seek end. Seek end means that places to the end of the file. Then next part is, that is the today's topic. Till now we have covered what we have covered in the last class. Now the next part, the next topic is low level disk input output. That is how we can take the low level disk input output, how we can take the input and how we can generate the output. This says in low level disk input output, data cannot be written as individual character or string as a formatted data. There is only one way that can be, or data can be written in low level input output functions as a buffer full of bytes. So this says low level disk input output data cannot be written as an individual character or a string of character, but data can be written in a low level disk input output function, that is as a buffer full of bytes. Writing a buffer full of data resembles the fwrite end function. That is, resembles means it is the usage of the fwrite functions. However, unlike fwrite, the programmer must set up the buffer for the data, place the appropriate value in it before writing, and take them after writing. That is, we have take them, or we have placed the buffer for the data, places the appropriate values in it before the writing, and take them after the, or take them out after the writing. Therefore, the buffer in the low level input output functions is very much a part of the program rather than being invisible as in high level disk input output function. That is, we use the buffer for the low level input output that is very much visible or invisible. Then we use the high level input output functions. That is, the main advantage is that when we use the low level formatting, we use the buffer for storing the value. That is, there is no concept of the character, there is no concept of the string, but there is a buffer in which we can store the data and we can put the data for multiplication or for calculations. Next point says low level disk input output offers three kinds of advantages. That is, it offers three advantages, or the following advantages, not three, following advantages. There are two advantages. Now let's see what are the advantages. Since these functions parallel the method that the operating system uses to write to the disk, they are more efficient than the high level disk input output function. This is, since these functions, means what are the functions that is used? These are the low level disk input output functions that makes the operating system uses to write to the disk, that are more efficient than the high level disk input output functions. Next point says, since there are few level of routine to go through, low level input output function operate much faster. Why? Because there are less number of routines, there are less number of functions that is used in low level input output. So the speed is very high as compared to the high level input output functions. So in simple terms, when we use In simple terms, when we use a low level input output function, it is very beneficial as compared to the high level input output functions. Let us now write a program that uses the low level disk input output functions. Earlier we have written a program to copy the content of one file to another file. This is earlier means before this we have written one program that copies the data from one file to the another file. In that program we had read the file character by character using fgetc function. So which function is used? One is fgetc function is used for getting the data or for taking the character by character data. Each character that was read was written into a target file. That is done by using the fputc function. Means which function is used? That is known as the fputc function. Instead of performing the input output on a character by character basis, we can read a chunk of bytes from a source file. Means instead of using the character by character spacing or character by character reading, we can read a chunk of byte. Chunk of byte means a group of bytes from the source file and then write this chunk into the target file. Means this is the advantage that we cannot waste our time in reading one data to another data to another, and so on. Instead, we can use the buffer, we can use the string in which by which we can achieve the target, and we can achieve we can save our time. While doing so, we would manage the buffer ourselves rather than relying on the library function to do so. This is what is low level about this program. Here is a program that shows how this can be done, how we can copy the data and how we can make the file copy program. This is the file copy program which copies text, .com and the exe files. This is the hash include function. This is again the hash include header file. That is, this is fcnt and this is type.h. If present in sys directory use. This is the next header file, that is stat.h. Now uses the main function. These are the various arguments. This is the most important. One argument it is used, this is argc. One argument it is used, that is argv. So these are the two arguments that is used. These two arguments will be discussed in the next chapter, maybe in the today's class only or in tomorrow's class. But these two arguments are the most important part. One is argc, one is argv. argv is of array type and argc is of integer type, right? Then uses the variables, that is buffer, that is array variable that stores the data from 0 to 511. That is, it stored 512 data that is of character type, that takes 512 bytes in the memory. Then uses the source and the target. These are also two array variables that gets the data and that stores the data of 128 and the 128. Then uses three variables of integer type. What are the three variables? In handle, out handle and the bytes. Then uses the printf function. It will print the line or statement onto the screen, that is enter the source file name. Means enter the source file name, enter the name of the source file. Then get source. This is the most important part. Gets is used in place of the scanf. Why? Because the file name may be of multi-word characters or multi-word string, and scanf does not accept the multi-word string. So we can use, or we use, it is mandatory or it is beneficial to use the gets instead of the scanf. Why? Because it is of multi-word string. Then uses the in handle. In handle is also a type of variable that is used to get the data, that is open, means opening a file. Uses source o randomly. This is o randomly, o binary. That is, we can access the data in read only mode or in bind only mode. Now check for the condition. If in handle equals to -1, that is, if it is equals to -1, then simply puts or printf cannot open the file. That is, if it is -1, if it is 0, then it's okay. If it is -1, printf cannot open the file, then exit. Means till now we have covered for fp, but that is using the file pointer. But in this we are not using the file pointer. Instead we are using a variable. What is the variable name? That is in handle, and check for the condition for the -1. That is, if it is equals to -1, simply printf cannot open the file, exit. Otherwise, printf enter the target name. That is, if it is not equal to 0 or it is not equals to -1, means that contains something. So then printf enter the target file name and then gets the value by using the scanf, or in place of scanf, that is target. Then uses another variable, means this is the for the handle, that is how to get the, or how to open the source file, and how to get the data, how to take the data from the user. Then out handle is used. This is also used for opening a file. Then uses the target. One is source, one is the target. Then O create, that is first of all create the file. Then O binary, O wrongly, S I write. So these are the various modes in which we can open our target file. Either we can create, either we can use in binary mode, it is wrongly written, or it is I write, that is we can write the data. Now again check for the condition. If in handle equals to -1, this is not in handle, this is out handle. This is by mistakenly it is used. It is given, please not make a note of it. That is, it is out handle, not the in handle. If it is again -1, then puts cannot open the file. That is, there is no or there is nothing in this one. Then close the in handle. Then there is a exit function. Now uses the while loop. This will never terminate because it is 1. So this will execute n number of times. Then uses bytes equals to read. That is, bytes is also a variable. This is the variable bytes that is used to read. How what is the read, or what is the file that is read? That is the in handle. Then buffer 512. What is the buffer? This is the buffer. This is the buffer variable. Then check for the bytes. If it is greater than 0, then write the out handle. What contain out handle? That is the target file. And in handle means source file. Means simply read the source file, and the buffer 512 bytes. That is clutter of the, or aggregate of the all the data in the file, that is a source file. If it is greater than 0, then simply write out handle buffer bytes. Else, if it is not equal to 0, then simply break the statement, close the in handle file, and close the out handle file. So in simple terms, this diagram or this example says how to use the variable without, or how to get the data without using function pointer. And in this there are two variables that is used. One is in handle, one is out handle. In handle contains the source file, and the out handle contains the target file. Means from where we can fetch the data, that is a source file, that is the in handle file, and where in which we have to store the data, that is a target file, that is a out handle file. And buffer is a like a buffer memory. We can use it for storing the data. This is the example. And then closes all the files. Curly brace close. Now how to declare the buffer? The first difference that you notice in this program, we declare a character buffer, this one, right? This is the buffer in which data read from the disk will be placed. As I told you, when we use the low level disk input output function, we use the buffer instead of the set of characters or string, or character or string. The size of this buffer is important for efficient operation. Depending on the operating system, buffer of certain sizes are handled more efficiently than the others. That is, it depends on the operating system. Okay, buffers of different types means there are if there are multiple sizes of buffer, it can read out or it can handle more efficiently than the others when we use the, or when we declare the buffer. Then next part is opening a file. That is how we can open the file. We have opened the two files in our program. One is the source file, one is the source file from which we can read the information. Other one is a target file, and into which we can write the information. So one is the source file, one is the target file. Target file is used to read out the data, and source file is used to read out the data, and target file is used to write out the data. This is what we have covered in the low level disk input output functions. Next point says, as in high level input output, that is when we done, or in high level input output, when we use the set of characters, set of or the characters or string, the file must be opened before we can access it. This is done using the statement. This is the statement. This is the handle equals to this one. That is file. Before the file is opened, we can access it by using this one. We open the file for the same reason as we did earlier, to establish communication with operating system about the file. That is, we open the file for the same reason as we did earlier. How that will be used? That is done by the fopen function to establish a communication with the operating system about the file. As usual, we have to supply the open function. The same, but in this or in that we have used the f.open or fp.open or fp equals to f.open, but in this we have used the variable that is of integer type, but again uses the open function, the file name and the mode. Mode means either we can open the file in binary mode or this is read only mode. So these are the various modes that is given after this. One is append, that is open a file for appending, creates a new file for writing. This says has no impact if a file already exists. Then randomly, that is creates a new file for reading only. Then creates a file for reading and the writing. Then creates a file for writing only. Then creates a file in binary mode. Creates a file in text mode. So these are the various outcomes or various modes in which we can open the file. These O flags are defined in the file fcntl, that is a flag counter or flag cntl.h. This is the header file that is used. Which is the header file? First one, that is fcntl. When this says, yeah, so this file must be included in the program with or by using low level disk input output functions. Note that the file stdi.h, that is a standard input output.h, is not necessary for low level input output. When two or more O level flags are used together, they are combined to use the bitwise operator. This is another statement that is used. Notice that in the target file is not existing while it is being opened, and we have used the oCreate flag since we want to write to the file and not read from the file. This is in various mode, but is one is OR only and one is O binary. Whenever we use the oCreate flag, another argument must be added to open the or to use the open function to indicate the read-write mode. Now what are the criteria or what are the position or what are the modes that is available for the target file? What are the permissions is used? What are the content? What are the argument? What are the vendors? The first one is, or the permission arguments are si write, that is writing to the file that is permitted. That is we can write the file, or we can use the si write to write the file or write to the file that is permitted. One is si read, that is read from the file that is permitted, that is reading from the file permitted. To use these permission, both the file, this one and this one, to be included in the program. This is what we have attached. This means we are sure that these files are guaranteed or these files are effective, that is used. This is stat.h. This is types.h. So these are the two parameters that is used for writing to the file that is permitting, or reading from the file that is also permitted. That is, this is a challenge, or this is the scenario in which we can use the data. Now, file handles. Instead of returning a file pointer, as I told you, instead of using the file pointer, we can use the fopen function In low level it is open is used. So instead of using the fopen as we done in the high level, we can use the open function that returns an integer value known as file handle. This is a number that is assigned to a particular file, which is when used refers to the file. If it return to 0, it means that the file does not contain anything. Larry, you are not able to hear me? Now it's audible to you? Hello, 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 hello. I increase my. Okay, okay, okay. Thanks. So this instead of using the fopen function, we have used the only open function for getting the output, for reading the output. So we have used the fopen in the high level input output, but we have used the open function in the low level input output functions or low level input output handle. If this returns a -1, it means that the file could not be successfully opened. Now, what is the main difference between the buffer and the file? The following statement treats the file as much of it as it will fit into the buffer. That is the following statement. This is the statement that is used to read the file as it will be fit into the buffer. This says bytes equals to read in handle buffer 512. This is the line that is used. This read function that is used for reading the file takes three arguments. One is the file handle, that is the file name. Second is the address of the buffer. Third is the maximum value it can store. So buffer can store 512 as we defined. So it is 512. This is the variable that is used. This is the name of the file. The read function returns the number of bytes actually used. How much byte it is actually used? This is 512 bytes. And we will know just how full the buffer is before we can do anything with its content. In this program, we have assigned this number to the variable bytes. For copying the file, we must use both read and the write in a while loop. Right. Note that when a large buffer are used, they made a global variable, otherwise using the stack pointer or stack overflow occurs. Now, next part is input output under Windows. That is how we can use the input output within the Windows. This is as said earlier, input output in C. It is carried out using functions present in the libraries that comes with the C compiler. That is whenever we use the input output, or whenever the input output, that is taking the input and generating the output, is carried out in C, or we have used the input output in C that is present in the library that comes with the C compiler, target for the specific operating window permits several applications. So whenever we use the input output under the Windows, means C is a programming language, right? But this programming language also runs on one application, one operating system. Suppose it is executing on operating system, that is Windows. So it is going to use with the C compiler that is target for the specific operating system. That is, we have to use the specific operating system for running the C compiler input output functions, right? Hence, there is a possibility that what is written by one application to the console may get overwritten by the output sent by another application to the console. This means whenever we use the input output under Windows, there is a chance of the duplicacy. So this error or this limitation can be removed by using the functions, that is the console input output functions. As I told you, console input output, we have used the console input output functions in the next chapter. Oh, sorry, in the previous chapter we have discussed about the console input output functions. It uses a separate mechanism to send the output to the Windows representing an application. So what is the criteria? Simply it uses a separate mechanism or the different mechanism which is used to send the output to a window representing an situation. That is, it uses the another pointer detail or the separate pointer, separate mechanism to send out the data to the window so that there is no duplicacy among the input and the output. The details of this mechanism, that is how we can use the input output under Windows, can be discussed in the next chapter, or sorry, in the chapter number 17. Though under Windows, console input output functions are not used. That is, whenever we use the window console input output, the following functions are not used. What are the functions? One is fprintf, fscanf, fread, fwrite, sprintf, scanf. But these functions are still in working. This says, though under Windows console input output functions are not used, but these functions will work exactly same under Windows as well. What are the functions that is used? That is fprintf, fscanf, fread, fwrite, sprintf and scanf. So these are the various functions that works exactly in the scanf function, or that works exactly in the Windows as compared to the different operating system, that is Linux, that is on the basis of DOS or the Linux. And so this chapter is finished. Now next part is your summary. This is the summary. There are total 8 points of this chapter summary. But please focus on this. Read carefully. First point says, file input output can be performed on a character by character basis, line by line basis, record by record basis, or chunk by chunk basis. That is, we can give the input, we can take the output either in a console manner, either in a line by line manner, either in a character manner, either in a record by record basis manner, or either in a group manner, that is a chunk by chunk basis. Different operation that we perform. Next point. So this is the point that is finished. That is, we can make the input and output on the basis of character, on the basis of number, lines, record basis, and chunk by chunk basis. Next point says, different operations that can be performed on a file are. Means, what are the operations that we can use in performing on in or that we performed on a file? What are the operations? First one is creation of a new file, opening an existing file, reading a file, writing a file, moving a file, and closing a file. So these are the various operations. Now let's see the functions. For creating a file, we use the create function. For opening a file, we use the fopen function. For reading a file, we use the fscanf function. For writing the file, we use the fwrite function. For moving the file, we use the fseek function or the ftell function. Closing a file, we use the fclose function. So these are the various operations that is performed, and there are various these are the operations, and there are various functions that is performed on the file. Next point says, file input output is done using a buffer to improve the efficiency. That is, we have used the file input output function to increase the, or using the buffer to improve the efficiency. Whenever we use the buffer, that means we are using or we are dealing with the low level input output functions. A file can be opened in a read text mode on the binary mode, depending on the or depending upon its contents. Library function such as this one convert this one into this one on vice versa. Smile or while reading or writing to a or writing or from a file. Many library functions converts a number to numeric string before writing to a file. That is, many of the library functions or the many library function converts a number to a string before writing a file, thereby using more space on the disk. That can be avoided by using the fread and the fwrite functions. That is, whenever we use the fread and the fwrite function, there is no conversion between the numbers and the characters, bytes and the characters. Next point says, in low level file input output, we can do the buffer management ourselves. That is, whenever we use the low level input output, we can do the buffer management by ourselves. There is no criteria in the system that we can do the buffer management. These are the various questions that is on the basis of this chapter. Now pick out the error in this. Now let's see this program. There is a hash file. Now first of all, let's copy this program. If it is copied, simply I copied this program, whole program, right? And I open my Turbo C++. Look over here. This copy paste is not working over here. Why? Well, this is not copy paste content. Right. So now let's see what is the error in this. This says point out the error. First of all, stdi.h is used, that is a standard input output function used. Then there is a main function. Then there is a file pointer fp, that is a one or more option is used, or one more variable is used, that is a file pointer fp. Then uses open file, that is my text or my file text dot or comma fp. Then uses or check for the condition. If fp equals to null, that is a pointer equals to null, then printf unable to open the file. So this is the correct way how we can open the file. Tell me. No, this is not the correct way. Why? Because we are going to use the fopen function instead of the open file. There is no function that is available like open file. So this is the error. That is, there is no function that is of type open file, but the function name is fopen. That this or that function is used for opening a file. So open file is not a function, but the function that is used in place of it is fopen function. So this is the error that is in this. Clear? Again, this is the error because whatever the function we define, this is declare, or this is defining, or this is declaring, or definition of this function is here only. So these are the various programs, that is how we can use. Now this is okay. We have used the file pointer for getting the value, or for opening a file by using the file pointer. There is a it is equal for the null, right? Then uses puts, this is this one. Now Larry, can you tell me what is the error in this? Hello? Yeah, Larry, can you tell me what is the error in this? Read it carefully and tell me the error. Hello? Okay, so what is the error in this? But puts is okay. Why? Because we are using the multi-word string, we are displaying the multi-word string. This is okay. This is used for printing on the screen. Is used for multi-word string. But the main error is that I will tell you the error. The main error is that this null, that is the null character, is written in the, is must to be write into the capital letters. That is, it is in the capital letters, not in the small letters. Okay. So this is the error, that is, it is written in small, and the compiler does not accept the small values. This is again the next program. This is the TR, and this is the error that is used because TR is not any mode. We have studied about the A, that is append, read, write, but there is no mode that is a TR mode. So this is the error. That is, there is no mode as for the TR mode. This is again the next function, or this is again the next code that is used for searching the errors. These are the various programs. The macro that is used, this is the important question. The macro file, that is we have defined the file in every condition, like this one, right? So where the file will be stored? It is stored in this file, this file, this file, or this file. Yeah. Can you tell me, Larry, in which file or in which macro the file is defined, or in which header file the word macro is defined? Which one? stdio.h, because we have used only one header file in every program, that is stdio.h. So this file must be stored in the stdio.h, right? Okay. This question. It is necessary that a file creating in text mode must always be opened in a text mode for subsequent operations. This means whenever we open the file in a text mode, so it is mandatory that this mode or this file must be opened in the this mode only, that is a text mode only. The answer is no. Why? Because we can also open the file in binary mode, that is a binary form, right? So these are the various questions, these are the various examples about this chapter. These are the various scenarios. Scenario based question structure will be defined, about listing of the program. Now, chapter number 13, that is more issues in input output. That is the continuation of the chapter number 12. This is the ARGC. So this is only the continuation, means the additional part of the chapter number 12, that is the more issues on the input and output. So first of all, let's take a break, then continue with the practical approach, not with the chapter number 13, but continue with the practical approach. Then if there is a time left, then we proceed to the chapter number 12. Otherwise, we are doing only the practical approach so that your concept is clear, right? So let's take first of all break, then continue with the practical approach. So let's take a break. Uh, so come back from the break. Let's start with the session, or let's continue with the session. So let's continue with the practical approach. Now tell me, Larry, what is your doubt? First of all, I clear your doubt. Okay, because there is no other student today in the class, so it's better to clear your doubt. So tell me the doubt. Yeah, yeah, sure. Okay, okay. So what is the mistake? Okay, so you are using the stdi.h header file. So what is the error? Not declare. You are so just do one thing. Yeah. Your colleague has done this program. Okay. So now you understand the concept. What your colleague does? Have you introduced one header file? Okay, okay. Now it's error. Mhm. Now error will be resolved, or if there is any error right now. So now if, now tell me if you have any doubts. Any other doubt? Okay, okay, okay. Now every concept is clear, right? So let's move to the practical approach. Okay. So I'm writing one simple program first of all using the for loop. And now then we have gone to the next program. You know what is a for loop? Suppose I have to use the number. I'm doing this. Simply write hash include stdio dot h, right? Then I've used hash include conio dot h. This is not this bracket, this is only this bracket, right? Then using void main, then there is a parenthesis, right? Then uses curly braces, then uses int. Suppose I'm calculating or I'm getting the number, let's example a, right? Then uses for loop, and starting with the brackets, first of all I have to initialize the variable, that is for I equals to 0, let's example. Then I is less than equals to 10, then I plus plus, this is the loop. Now I'm using one more curly brace for calculating the table, that is the sum. For example, I'm taking a equals to, this is starting with this one, for example 1. So this is a equals to I, every time it will be incremented, into a. Now curly braces will be closed. Now if I execute this program, there is an error. There is an error. What is the error? Declaration not defined, or declaration syntax error, because I have not closed this curly brace, right? If I close this curly brace also, now let's see what is the error. There is one error. This is declaration syntax error. That is, what is the declaration syntax error? This v should be small. So this is what I showed you, that this is not a case sensitive. If I use capital V, this is not okay. I have to use the small v, right? Now if I execute, this is also an error. Undefined symbol I, that is, the I is not defined over here. Now I have defined this one. If I execute, this is success, that is done. Now I'm not getting the output. Why? Can you tell me, Larry, why I'm not getting the output? Because I've not used the getch function. So it's mandatory to use the getch whenever I want the output. But if I want to show the output, or if I want to see the output, simply press Alt plus F5. This is the output. Nothing is the output. Now if I use getch over here, right? Now if I compile the code, now the output screen will be displayed, but there is no output. Why there is no output? See, if I am using a, there is no value in a, so how it can calculate with a? So I have to define this value. Suppose I have to take the table of a 2. This is 2. Now if I compile this one, this is nothing. Why? Because this loop will never terminate or never execute. This is a equals to 2. This is 2 into 1. First time this is 1, so this is a equals to 2 into 1, that is stored in the 2. Again the a value is becomes, or the a value is right now 2, right? Now again the I plus plus, that is 2 into 1 is, or the 2 into 2 is 4, then 4 will be output into this, then next part, next part, next part. So this will be displayed till 10 times. But what is the output, or where is the output? Now if I execute this one, there is no output. Why there is no output? This is 2, this is I. There is nothing error. There is no error, but there is no output. So, anyone, or Larry, you are the only one. Can you tell me why? What is the error in this program? This is the basic program. So what is the error? Are you able to hear me, Larry? Hello? Hello? Hello, hello, hello. Yeah, are you able to hear me? Hello? Hello, 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 hello.